Hi everybody, this is Ramji Sharma. In this video, I will solve a problem that is related to the first order partial derivative of a function of several variables. This is the only problem that we'll be solving in this video. The problem says, given f of x comma y equals 4x squared minus 5xy plus 4y squared plus 5x plus 6y, find the value of y where f sub x, x comma y equals 0, and f sub y, x comma y equals 0. If you are not familiar with these notations, then please review the notations for the partial derivatives of a function. Here, f sub x, right here, let me bring this pen up. So f sub x here is the partial derivative of f with respect to x. What that means in short is that we'll differentiate this function with respect to x, keeping the variable y fixed, or treating y as a constant. Similarly, f sub y right here means we're differentiating this function of two variables, x and y in this case, with respect to y by treating x as a constant. Hopefully you've already reviewed those basic topics on the first order partial derivatives. Hopefully this example will help you understand those concepts a little bit better. Alright, so let's just go ahead and do this. I was trying to change the color of the ink and it didn't work, so let's see if it works now. Okay, so I have f sub x, xy, or I'll probably just drop the xy because it's kind of understood. So let me just write f sub x equals, so let me remove this extra mark here. Alright, f sub x, which is the partial derivative of f with respect to x, equals, now here there are variables, both x and y, in these expression. Some of the terms contain only x, some of the terms contain only y, and some of these terms contain both x and y. Now if you are doing the derivative with respect to x, then the terms containing x will be losing one power of x, whereas the terms containing only y will be treated as a constant, and if you recall, the derivative of a constant is 0. So in this case, the first term, 4x squared, is going to become 8x because you just move the power out in front. So 4 times 2 is 8 times x to the power 2 minus 1. I'm thinking of the power rule here. Minus, the second term contains x and y. The y here is a constant with respect to x. So the y is not going to change in this case. Only the variable x is going to be affected. So you're basically treating this 5xy as 5 and y altogether as one constant, and then x. So you're basically differentiating x with respect to x. So that's going to be 1. So it's going to be 5y because the x becomes 1 when you differentiate. I hope you recall the derivative rules from the previous chapters. Plus, now the 4y squared does not contain any x, which means this whole entire thing is a constant, and that will become a 0 when you differentiate it with respect to x. Again, remember, we're differentiating with respect to only one variable at a time. So, well, I made this even worse. So let me erase this whole thing and rewrite this. So we're just differentiating with respect to x at this time. All right, and then plus 5x is the term containing x, so that's going to be just 5. And 6y is a term not containing x, so it's a constant in terms of x. That's why its derivative with respect to x is going to be 0. So let me simplify this and rewrite this as 8x minus 5y plus 5. And so the question here is to find the value of y where f of x equals 0 and f of y equals 0. So let's go ahead and find f of y, and then we'll set them both equal to 0. F of y now will become the derivative of this function f of xy with respect to y. Now, unlike the previous case, this time the variable y becomes active, so anything that has to do with y will be differentiated using the power rule or whatever rule you'll have to apply, and the terms containing only x or anything that has to do with x will become a constant, and then they will not change. And differentiating means finding the rate of change. So if something is constant, the rate of change is 0. That's why you will see that kind of thing going on here. So we're going to go back to the main function again and differentiate this with respect to y. So the first term, 4x squared, is completely independent of y. It's just x squared and 4. So the whole thing here is a constant, and the derivative of this constant is 0. So that's a 0 minus. The second term contains x and y both. But this time, 5xy, because we're doing it with respect to y, so this 5x, 5 and x as a product, 5x, will become a constant. So it's basically a constant times y. And the derivative of a single power is just 1. So it's just going to be 5x. Now remember, we're doing it with respect to y. So the derivative of y with respect to y is 1. If you are thinking of the implicit differentiation, then the derivative of y with respect to something else, maybe with respect to x, is going to be dy over dx. This you can think of as dy over dy if you are thinking that far. But you don't even have to go that far. Just apply the power rule. Plus, the next term contains 4y to the 2, which is a term containing y, and the derivative of y squared is 2y times 4 is going to be 8y, just as the derivative of 4x squared with respect to x is 8x. Plus 5x is a term independent of y, so the whole thing is a constant, and the derivative of a constant is 0. Plus 6y is the term containing y, and the derivative of y with respect to y is 1, as you saw in this example here. So it's going to be 6. Okay, and if you simplify this, that's going to become negative 5x plus 8y plus 6. Alright, so we got the values of f of x and f of y. Now we got to set them both equal to 0. So let's set the first one to 0 and the second one also to 0. And how do we find the value of y from these two equations? So let's call it equation number 1 and this as equation number 2. Alright, so it basically boils down to solving a system of linear equations in two variables, if you recall from college algebra. So you can apply all types of methods here based on your taste. I'm going to apply the method of elimination. So I'm going to eliminate the variable x because I want to find the value of y out of these two equations. So I'm going to multiply the equation 1 by a number which I'll have to find out here, and probably do the same thing for equation 2 so that I can have the same coefficients for x. So the coefficient for x here on the first equation is 8, and the coefficient for the y, the x in the second equation is -5. So since 8 and 5 don't have anything in common, so I'm going to multiply the first equation by the number in the second equation, basically, so 5, and I'm going to multiply the second equation by the coefficient 8 from the first equation. So if I rewrite these equations together, then I got 40x minus 5 times 5, 25y, and usually you might want to take these constant terms to the right side, but it's okay. Plus 25 equals 0, and in the second equation I have -40x plus 64y plus 48 equals 0. So again, remember to multiply all the terms containing, of the equation by the number in the front. So now we're going to apply the method of elimination. So we're just going to add these two equations together and cancel the variable x. So I have 64 minus 25 because the y and y like terms, so it's going to be 39 y plus I have 48 plus 25, which is a 73, equals 0. And I'll have to solve this one single equation now. So I'm going to subtract 73 from both sides, so it's going to be 39y equals -73, and dividing both sides by 39 gives me y equals -73 over 39, and that's going to give me -1.87. You can use a calculator to get that number. I think I rounded up to 2 decimal places. Let me double check. So I have, let me turn this on. So I have 73 divided by 39. So that's going to be 1.8717, and of course to the 2 decimal places that's going to be 1.87, and the negative sign is coming from the previous line. That's the answer of this problem. So this is the only problem I have wanted to solve in this example here. So so what we did is we evaluated the partial derivatives of this function with respect to x and y, and then after we set them both equal to 0, and we ended up with 2 equations, 2 linear equations in 2 variables. So we applied the method of elimination to solve these equations, and we eliminated x and got the value of y, and that's the answer. Alright, I hope you learned something out of this. You can replay this video as many times as needed and try to solve this problem on your own. Okay, so I'll see you in the next video. Thank you for watching. Bye for now.